Okay, now we're going to look at properties of numbers. There are a lot of properties. You don't have to remember all these names, but make sure you understand the property. It will seem easy when we look at it, but I promise you it will get more difficult. You have to know it very well or you'll struggle later on in the year. So the first thing is transitive property. So it might sound a little bit confusing when you read it, but basically what we're saying here, if 2 plus 3 is equal to 5, and 5 is equal to 4 plus 1, then that means that 2 plus 3 has to equal 4 plus 1. They're the same. Okay, now if we say it using algebra and only variables, if A equals B and B equals C, then that must mean that A and C are the same. Again, it sounds more complicated than it really is. Substitution. You can substitute anything for its equal. So if you know x is equal to 4, and you have an expression that says 2x plus 9, you can substitute the 4 in for x. So it's 2 multiplied by x plus 9, so 2 multiplied by 4 plus 9. So that's 8 plus 9, which is 17. It could also work if it's a little more complicated. Let's say x is equal to 2y plus 3. So if I have 2x plus 9, I can still put what x equals into the equation for x. The only thing that changed is I took what x and I put what it equals, which is that. Additive inverse. That's used a lot to solve equations. So these are additive inverses, 4 and negative 4. They equal 0. Negative 5 and positive 5. They equal 0. Remember, it's the same even if it's variables. If I say negative xy plus xy, it's 0 because they're additive inverses. Multiplicative inverses, two numbers whose product is 1, also known as reciprocals. So 3 over 4 multiplied by 4 over 3, 3 times 4 is 12, 4 times 3 is 12, that equals 1. Those are multiplicative inverses. You will use those all the time to solve equations that involve fractions and division. So remember that. Multiplicative inverse, you're multiplying by the reciprocal. Multiplicative identity. The product of any number and 1 is the number. Seems simple. 5 times 1 equals 5, but it's going to be a much more complicated other times. Now you've already used this before to solve fractions. Say I want to add 2/3 and 4/9. I can't add these because these do not have common denominators. So I'm going to multiply 2/3 by 3 over 3. 3 over 3 is just another way of saying 1. 3 divided by 3 is 1. But I use that to change 2/3 into a form that I can work with it. So it doesn't change the value. It just changes it to a form that I can work with it. Multiplicative property of 0. Any number multiplied by 0 is 0. So 4 times 0 is 0. But it gets a little more complicated. What if I have 4 multiplied by x? And I know the answer is 0, so that must mean x has to be 0. Because if I'm multiplying two things and the answer is 0, one of them has to be 0. What if I make it a little bit more complicated? What if I take 4 and multiply it by -3 plus x, and the answer is 0? I still have two things that I'm multiplying. I have the 4, and I have the -3 plus x. One of those has to be 0. Well, 4 is not 0, it's 4. So what's inside this parentheses needs to equal 0. So that tells me that x is equal to 3, because -3 and +3 will add to 0. Those are actually additive inverses. And the last one is the associative property. The order when multiplying or adding groups of numbers does not matter, but sometimes it can help you to do it in one order or another. For instance, if I'm adding 17 plus 25 plus 13, I might decide to add 7 and 3 first, because those add to equal 10, and that makes it a little bit easier. So look for things that can make it easier when you're doing that. If I have a multiplication problem, 2 times 16 times 5, order doesn't matter, so I might multiply 2 times 5 first because that's 10, and I know it's easy to multiply by 10 because 10 times 16 is 160. So just look for order. Sometimes that means multiplying the smaller numbers first because that might be easier.